Okay, tickets at a school talent show cost $2 for students, $3 for adults. So it's 2 times the number of students plus 3 times the number of adults. If Chris spends at least $11, that's greater than or equal to 11, but no more than 14. So let's think about that. No more than 14. Does that include 14? Yeah, it could be 14. So it's going to be less than or equal to 14 on X student tickets and 1 adult ticket. So we know we have 1 adult ticket, A equals 1. Okay, so we have 2 times the number of student tickets plus $3 is going to be greater than 11 and greater than or equal to 11 and less than or equal to 14. Right away, if S equaled 4, and let's just set this up, S equals 4, the total cost, C, is going to be 2 times 4, 8, plus 3. It's going to be 11. If the number of student tickets is 5, it's going to be 2 times 5 plus 3 is 13. If S were 6 student tickets, it would be 6 times 2, 12, plus 3 would be 15. 15 is too big. That's not in our solution set. Only 4 or 5 students will be in our solution set. So either answer will work for 31, 4 or 5. The ages of the first 12 U.S. presidents. Okay, we've got a table of 12 numbers. What do they want? When they began their terms in office, according to the table, what was the mean age in years of these presidents at the beginning of their terms? Let's double just check that is the beginning of the terms the data. Okay, we just simply need to calculate the average or the mean, not the median. Be careful, the average. Okay, and that's of 12 numbers. So I could literally sit here and just plug these numbers into my calculator, divide by 12. Instead, I'm going to actually assume an average of 58. That is my expected average. So I'm going to do this without a calculator. Okay, relatively easy. My expected value is 58, and I'm going to look at the sum of the differences and take the average of those instead. So 57 is minus 1 relative to 58. 62 is plus 4, so that's a rolling sum of plus 3. 58, 58 don't change anything because they're our average or expected average. 59 is plus 1, so that leaves a plus 4 rolling average or rolling sum. 58 doesn't change it, so I start with plus 4 here. 62 is another plus 4. That makes my sum plus 8. 55 is minus 3. That makes my sum plus 5. The difference is 68 is a whopping plus 10, so that makes my sum a difference is 15. 51, however, is a minus 7, offsetting that. That makes my rolling sum 8. 50 is minus 8. That makes my rolling sum back to 0, and I've just lost 7. So my rolling sum is 7. The answer should be 58 plus our remainder, 7 divided by 12. The answer is 58 and 7/12. And by the way, 1/12 is 0.0833, etc. So 7 times that is going to be 56. This is going to be roughly 58.56, and then 21, about 58. So 58.6 if we round it to the nearest tenth. Okay, looks like we have the addition or subtraction, actually, of polynomials. If the expression is rewritten in the form ax squared plus bx plus c, where a, b, and c are constants, what is the value of b? Well, b is the coefficient of the x variable. So all I really need to do here is sum my x variables. It's going to be plus 1 times 5x, or 5x, minus 2 times minus 2x. Don't forget the negative coefficient to the parentheses and the negative 2x inside. So that's going to be plus 4x. The double negatives cancel and become positive. So the answer is 9x for the x term, which means b, the coefficient of x, equals 9. In a circle with center O, central angle AOB has a measure of 5 pi over 4 radians. Well, we know pi radians is half a circle. So actually, this angle is going to be, if we think about it, it's going to be more than half a circle. So whatever fraction we get, the central angle AOB is what fraction of the area? Or actually, the area of the sector formed by central angle AOB, that is this area as a fraction of the whole circle area, should be, just conceptually looking at it, greater than a half. So that's going to be a common sense check for our answer. So how do we do this? Well, remember, the area of the sector to the area of the circle is equivalent to the central angle of the sector divided by a full rotation of the circle, which is 360 degrees, or in this case in radians, 2 pi. So my fraction is simply 5 pi over 4 divided by 2 pi. That's essentially my arc area to my circle area. Remember, we don't care about the radius. That's not part of the program. Each is multiplied by the radius squared for the area. Those cancel out. So the simple answer is pi's cancel out as well. It's 5/4 divided by 2, which is 5/8. The correct answer for the area of the sector divided by the area of the circle is 5/8, which is a little more than a half. It makes common sense as a check.